So our next speaker is Stéphane Schmitt. Stéphane Schmitt has been working for METEORAGE for more than 20 years. He's a Lightning application expert involved in the international standardization committees, IEC, and appointed by Meteor France to the World Meteorological Organization. He's a contributor to international standards such as IEC 62793, 62858, or 62305 series. He participates in works and publishes studies in the field of lightning risk assessment and prevention and all actions to promote lightning safety. Stéphane.
Thank you very much, Dale. So, hope that you can see my screen. Not sure. Okay, maybe like that. Try to do full screen. So thank you very much. Thank you very much for the introduction. And I'm very pleased and honored to be here with you.
Dale, are you hearing me?
Yes, yes. Hello.
If you want, I can give my lecture and then Stéphane can continue.
Yeah, sounds good. Thank you.
Okay, may I start?
Yeah, thank you.
Yes. Thank you for inviting me, Marianne and Dale. I will talk about a recent study on the protection of people against lightning. Are you seeing my screen of the PowerPoint?
We're seeing, yes.
Yes? Okay. Okay. I will talk about 3 papers that we are studying. The first one is one paper that we present in SIGRE, ICLPS, and CIPIDA last year, October. And we will talk about the risk analysis with upward unconnected leader in human beings. In this paper, we made a simulation using human body models and using the UL currents on the head of the people. We use this model for a human body, and then we made 4 cases. The first case is using this current, and this is the current on the heart of the people. And the case 2, case 3, and in this case 4 is using an oscillogram. It's a real oscillogram from NAG that they obtain in a tower, and you use this oscillogram as is this on the head of one people, and here the current on his head. The second paper is entitled "Are You Safe from Lightning Inside Buildings? A Study of Lightning Fatalities Inside Buildings Using Smartphones." This is the authors. And this paper was presented at the beginning of this year in Tucson, USA. The motivation for this paper is that in 2022, a series of fatal accidents were observed. 5 people were died using the smartphone. So we made some study using this human body simulation, using this model simpler than the previous one. And we made some measurements, a frequency response measurement on the charges into input in play, and the measurement of the frequency response of coupling between the vitamins hand and the smartphone. So this is the complete circuit model. We consider the lightning strike in the medial voltage and phase C, and here the transformer, the model of the transformer, considering the high frequencies, and here the current, the low voltage line, and here the charger, and the hand, coupling the smartphone with the hand, and here the human body model. In this case, we input this current in the medium voltage side, phase C, and this is the voltage, the electrical voltage in which the vitamins is subject in the hand of the vitamin. And this is the current circulating between the smartphones and the vitamins hand, and here the current circulating in the vitamins heart. And the third paper that I would like to show is injury mechanisms in lightning accidents, an analysis of the Brazilian case. This is the authors. I show this paper here in this the conference that is occurring here in Brazil now. And these figures, I think Marianne Cooper knows very well. This is, it was adapted from his figures. It's about the mechanisms of injuries. And we use 3 papers. One paper from Marianne Cooper and Chris Andrews and Ho about the division of the mechanism of injuries. In this case,
yeah, the email still works. I can log in from my own.
We study another paper from China. In this case, the directed current, directed strike is the higher. And I think that Chris Andrews we analyze another paper from Chris Andrews, and in this case, the upward unconnected leader is just higher than the first study because the step voltage, he considered that the people have to stay more the strike, the distance is less than they study before. And then in our case, we made a study analyzing 413 vitamins in that period, and 4 Brazilian experts study all the notices, and we analyzed and divided the injuries, and we obtained this result. And we can see here that we had direct strike, 91 cases, and 78 are fatals, and 97 for step voltage, and dot voltage 59, side flash 61, upward unconnected leader 71, and others. And this is our Brazilian pizza. We can see only for fatal case. And then I think it's okay. I have these 3 papers, and anyone that wants these papers, please send me an email that I can send for you. And it's okay. If you have some questions or if you want, I can continue about our live section if you.
Thank you. Is there any questions for Hélio? Marianne, do you want to chime in on the question? Well, Marianne was saying, sorry to spam everyone, but I cannot find Hélio separately. Chris Andrews' mechanisms column added to 90, not 100%. Please send me papers.
Okay, and Dale, if you permit, can I start the live sections?
Yes, please. I think we're gonna have the group photos. So everybody, if you can turn on your cameras, and we'll get a group photo and with the local people in Brazil.
Okay, I would like to show only our schedule of our event that are occurring now. This is our audience. Are you seeing?
Yes. Wonderful.
Okay. Okay. And now the people are our.
Hey, woo!
Oh, great.
Wonderful. Well done.
Okay, Marianne, if you permit, I would like to show 5 slides about our event. Can I?
Yes, please, go ahead.
Adelino, muda para mim, faz favor, para aquela câmera. Okay. Are you seeing our schedule? Okay. This is our ILSD Brazil this years. We have some lectures, some lectures about line protections and structures and our standard. We have about the mechanism of injuries and have another lectures about the safety guidelines and things about our standard. Okay, and we receive some videos from experts of all the world. Thank you, Marianne Cooper, for the video. Kazuo Yamamoto, Stéphane Schmitt, Alan Rousseau from IC, Ron Hull sent a video for us, and Shriram Sharma from Nepal. Thank you very much. This is the support and the sponsors of our event. And now I would like to show some pictures. It's the first time that I show these pictures. It's an world spoiler. In this case, this is my brand new son. I'm writing a book for children in Portuguese, Caminho Quase Suave. I think in English, an almost smooth path. And it's a book for children, how to protect yourself from lightnings. It's not ready. I have some pictures about, in this case, touch voltage. And here some recommendation in time of thunderstorm. And this is not color, but this is about step voltage. And the main message when thunders rolls goes to a LPS building that have protections. And then the first time that I show, and then thank you for the invite me for this participation in iOS USA.
Thank you, Hélio. You're great.
Thank you, Hélio, and thank you for the audiences in Brazil. Thank you for your time. Is there any questions for Hélio?
Okay, thank you very much for your invitation. Hello, Stéphane. Very good to see you again. And thank you for all.
Thank you. We'll come back to Stéphane's talk.
Let's try. Yes. So if I understand, Dale, you can try to, okay. Yes, thank you very much. Okay, that's perfect. And thank you again to, to Hélio and to the Brazilian audience. You're great. It's fantastic. Thank you very much. Thank you very much. Yes. My presentation is entitled Promoting Efficient and Standards Compliant Thunderstorms Warning Systems Everywhere. For that, I think that, okay, I cannot move the slides, I suppose, so maybe.
Just let me know when you need.
Yes, okay, if you can. Okay, so as an introduction, just to mention the fact that for many years, experts in lightning protection have been warning of the existence of non-conventional lightning protection systems, which often represent a danger to the protected. And for example, one of the last questions to Gopa for the Bangladesh case show that it's a real problem. And that's why experts from all over the world are helping to create international standards to limit this type of installation. Well, less publicized says that lightning protection system, thunderstorms warning systems also face this problem. Installing a portable detector or even sometimes some types of standalone sensors to protect the school in Africa, in developing countries, or even for your own association in a small village, for example, playing football outside, is well-intentioned, of course. However, it represents the same risk as installing a non-conventional lightning protection system. And that's why compliance with standards should not be limited to the installation of the reach. And just like lighting protection system and using homemade systems or systems enabled to prove their effectiveness according to a protocol described in the standards, and IEC 62793 is the same mistake as installing non-compliant lightning protection systems models. Next slide. So the question is, what is a compliant thunderstorm warning system? So the first is a system which is not based on an assumption or a pure theoretical principle which is not validated by on-site measurements. That's all. And whose real measured performance enables to achieve efficiency upper than 90 and 95% as described, for example, in IEC 62793. So how can we measure the efficiency of a thunderstorms warning system? In fact, it's very easy. You have just to calculate the time difference between an alarm triggered and a lightning-related event. described in standard has a cloud to ground in the vicinity. Then you just have to make statistics on a larger population of events to calculate metrics such as the probability of detection of a thunderstorm before it threats, and ideally PODX, which cover the lead time to reach safety and which depends, of course, on the activity, sometimes 10 minutes, 20 or more. So here, for example, I let the example that I had shown during the conference in Nepal. So it's a location in Nepal. And here, for example, it's 11:39 in the morning and an alarm is triggered because there's a lightning discharge 25 kilometers ahead. Then at 1:47, a cloud to ground is detected near location. This is a lightning related event. Here, the lead time was more than 2 hours. And then, next slides, please. So this is one example, 2 hours, and then we just have to make the same job on a larger population. So here again, it's not in Nepal, it's another nice place, as you can see in Stonehenge in UK. And in this case, for example, we analyzed more than 200 events, I mean thunderstorms, on a 10-year period. And then for each here, we calculate the same parameters. And here, for example, you can see that the probability of detection is 100%. Sorry for the acronym, but FTWR is failure to warn, so the contrary of probability of detection. So it means that on a 10-year period, using this kind of thunderstorm warning system, you achieve 100% of efficiency. It means that you are able to warn before a lightning-related event. And here, the POD 15 minutes, for example, calculated the fact that people can shelter within 15 minutes. So here again, it's 100%. And for 30 minutes, it's 90%. So it's typically the method that promoting by IEC 62793. As a conclusion, for the last slide. Thank you very much, Dale, and sorry again. Well, something changed. And today, and thanks in particular to standardization and, for example, IEC 62793, thunderstorms warning systems are considered as real safety devices in addition to lightning protection system, and not as gadget or optional gizmos. With the emergence of worldwide lightning detection networks, you mentioned, for example, in a previous presentation, GLD 660, for example, warning people anywhere in the world is no longer an issue, a technical issue. It's possible everywhere. We can warn people everywhere in the world, technically, by using lightning detection networks. So, this is not a technical issue. And of course, the first step is to encourage people to apply safety rules. And one of the most important safety rules is when thunder rolls, go indoors. This is fundamental. But when you're using a system in place of a human observer, and especially in industry or even in a soccer or a cricket game, you cannot blindly rely on a system, or worse, waiting for it to trigger while you can see or hear the thunderstorm. So I think it seemed to me an important message to send to all the ambassadors that we are. Thank you very much for your attention, and sorry for the technical issues, not on lightning detection, but on my presentation and the screen. Thank you.
Thank you, Stéphane. Any questions for Stéphane?
Stéphane, when you put your slide up, I noticed the POD 15 minutes was 100% and POD 30 minutes was 90%. Can you explain why?
Oh yes, for sure. In fact, we have created a statistical tool, so which include all the events and make as calculate the time difference between each lightning related event, and so the presence of the timestamp of the cloud to ground and the time, the warning, the trigger of the alarm. And so like this, you can calculate the time. So for example, in my first slide, it was 2 hours. So here, for example, POD 15 is 100%. If all the cases were like that, for example, if for every alarm it is 2 hours. So of course the POD 15 is 100%. The POD 1 hour is 100%. The POD 2 hours also 100%. And if POD 3 hours, so it's 0%. So it's the same. We took into consideration all the events, so more than 200 events, and for each of them we calculated this time between the triggering of the alarm and the cloud to ground in the vicinity. And in this case, for example, for my case in Stonehenge, in fact, it was to show that, for example, if you can evacuate people in 15 minutes, it's you have 100% efficiency. But if you are unable to evacuate people because they need 30 minutes, so it means that it's a 90% efficiency, or you can try to modify the parameters of the warning system, which is also possible to improve the probability of detection with 30 minutes.
Thank you.
Thank you, Mitch, for your question.